Hi, this is Suey778 coming at you, and today on the channel I've got another multimeter to review. Sorry for my absence in recent weeks, but when I get busy, I get busy. I have limited time to do these videos, so I do apologize for that, but we are back and we do videos as we can. Anyway, today's offering is the Kaiweets KM601. This was kindly sent to me by Kaiweets for my review, and I do want to say thanks to Kimberly at Kaiweets for sending this out to me. So this is available at Amazon.com for $45.99 and currently has a coupon for 10% off the last time I checked, which was earlier tonight. So let's go ahead and do the unboxing. As you can see, as Kaiweets usually does, we have a very nice looking box. So let's go ahead and open it up and see what we get inside. Okay, so we get a nice hard shell case, two sets of batteries for a total of 6. A user manual. Let's get the box out of the way here. And the manual, of course, has some specs here. Let me show you the specs. Okay, there are some of them. Hopefully you can see that. Let's see if we got any more. And we do. Kind of a wide manual. Hopefully that's focusing. Let's see if we got anything else here. And yet some more specs right here on the last page. So there you go. Alright, so there's that. Alright, so inside the case we get a set of leads, thermocouple, and of course we get the meter, and here she is in all her glory. This is the Kaiweets KM601. Okay, first I'm going to do a size comparison. So here is the HT112B in comparison with the KM601. As you can see, the 601 is significantly larger. It's about the size of a a regular full-sized cell phone. Let me bring out my LG G7 just to compare that. And as you can see, they are roughly the same size. Now the thickness is a little bit different. This one is fairly thick, and my cell phone, even with the case on, is not so thick, but about the same length, and this meter is a little bit thicker. Okay, so let's go from top to bottom here on the overview. Right up here you have a power button, which you can see right there. On this side we have a flashlight button right here, and then on the other side we have the automatic power off. The APO, when engaged, will go off after 15 minutes of inactivity, and you can toggle that on and off, fortunately. Obviously we don't need to worry about the display because this is a reverse EBTN display, so it's always on. Okay, down below we got a range button here, your auto and function button here. This is basically where you select whatever function you want to use or put it into auto. The select button here for sub-functions within the main function, a max and a min. Also have a rel feature on this, which is new for Kaiweets. This is the first time I've seen a rel feature in a Kaiweets actually. Well, the clamp meter before kind of had that, but this is actually a full-fledged rel. Also has freeze frame hold, and down below we've got, in fact let me just put it up here, we've got our COM jack, our functions jack, milliamps and 10 amps. These are fused with 250 volt fuses. This in theory anyway, is supposed to go up to 600 milliamps on the milliamp jack and then 10 amps on the 10 amp jack, obviously. 9,999 counts. There is no category rating in sight anywhere. Okay, let's go ahead and power this up and do the grand tour. As you can hear, it's got a high-pitched beep, not really loud. This thing does default to auto mode when it first powers up, and you have the choice of measuring voltage, resistance, or continuity. It also displays the ambient temperature. Unfortunately, it only does that in Celsius, so if you want to see it in Fahrenheit, you're out of luck. To put it into the manual mode, basically hit that red button, and first up is AC and DC voltage. And with the AC setting, this is true RMS, and you do get a Hertz function in the secondary display, so that's nice. Next up, of course, is your resistance. And as you can see here, these lights are beeping where you need to connect your jacks as we go along here. That's a carryover from the HT118A, and I'm happy to see that. So that makes that handy for new users. This is continuity mode. Next up is diodes. Next up is capacitance. Next up is AC and DC millivolts, and again with the AC settings you do get a dual display for the Hertz, which is nice. Okay, next up is your Hertz and duty cycle. Again, takes advantage of both displays. You get your frequency down here and your duty cycle up here, so that's nice. On your Thermoprobe settings, again, you get a dual display. You can't flip these, but at least you can see either Fahrenheit or Celsius depending on how you want to read that. I guess it depends on what country you're in. Next up is your non-contact voltage and your live function. And next up, as you can see, even for that, it's telling you that you only need to plug in the red the function jack. When we get to current, we do have, again, indicating here, this is milliamps, so you need to do those two as it was indicating, and then for the next one, amps, it tells you to use this jack. So again, pretty much works the same way as the HT118A. Your APO control indicator is right here. If you want to turn that off, just hit that side button and that icon goes away. And then on the other side, we got a flashlight. And there you go. Okay, so you have this protective rubber glove on here. So the first thing we need to do, actually let's show the batteries first. Actually, you're going to have to take the cover off to do that. So to change the batteries or anything else, you will have to take this protective cover off. So, ooh, that slipped right out of my hands. But anyway, should come off fairly easily. Yeah, no problem. So nice rubber cover. Actually, it's probably, this feels more like a synthetic material of some kind. But anyway, let's throw that aside here. And here is your battery compartment. Actually, you have to unscrew this whole panel for this. So let me get my screwdriver out here and let's take that out. Okay. And then you can just shake it and it comes out. As you can see, I've already got batteries installed in here. I'm going to go ahead and pull these out because we're going to go ahead and do the teardown. As you can see, we do have a brass insert for the battery compartment. So let's go ahead and take this out. Actually, you know what? We can just leave them in. So you have 4 screws to take this down. There, here, 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 and here. So let's go ahead and take those out. These are in there pretty tight. Okay. Okay. Now this gets a little bit tricky. You are going to definitely need a guitar pick for this to get this started. It separates right here. So you just want to start sliding a guitar pick down there. Okay, we got our parts. So you have to use one of these and one of these little pry tools. It's the easiest way to do it. Just don't force it too hard because you don't want to break anything. But anyway, so on the top cover here, the battery compartment is separate from the rest of it. And let's pull this aside and let's go ahead and put this sideways and let's do a close-up on this, shall we? So yeah, we're going to do it this way. As you can see here though, this is an interesting design. We've got a 2-tiered PCB here. So that's kind of neat. So let me go ahead and zoom in on this. Okay, here we go with the PCB view. As you can see, first of all, down here at the bottom, we've got the split type jacks. And it looks like, actually, it's somewhat different design here. It looks like they got a lot of protection down here. Lots of resistors. These are the same exact fuses that you would find in an HT118A, the 6mm by 23, I believe. They're both 250 volts. Your battery contacts, positive is here, negative is here. You got a single PTC right here. Good series of resistors here. A couple more here. Some clusters up here. These all look like resistors. And you might ask, well, where is the current shunt? Well, the current shunt, again, is like the HT118A. It uses that resistor rather than an actual piece of metal. So the current shunt is right here, that same exact one that you find in HT118A. However, they have added a MILF resistor in series with it as well. Looks like the relay. This is the relay for the auto mode. Here you've got some diodes put together. Some more over on the other side, maybe some transistors, a couple of nice capacitors sitting here as well. Those are not cheap capacitors. Main processor is right here, and this is an SDIC SD7502, if I'm reading that right. This one was manufactured in the 30th week of 2021, so pretty much brand new. This appears to be the speaker. Obviously this is the main processor. You got your calibration ports right here, and this, I'm guessing, probably controls the LCD. Here's the LED for the flashlight. Here is the mechanical switch for the power button, and then you've got your two switches. I believe APO and flashlight. It's one or the other. And the NCV antenna is soldered in right here and then goes up out to the top. This is the board is at HT116-1.V1 version 1.2. So totally new design. How would I rate this? Well, I would say this is probably a category 2 250 volt multimeter. But I do like, it looks like they have put more, attention towards protection. Maybe they felt like they only needed the single PTC, but even a couple of PTCs aren't going to protect a whole lot anyway. I mean, that's just the way it is. But I do like them adding that there for that. That was a nice touch. And, lots of, it seems like it's a little bit bolstered compared to the HT118A. So good thing to see. All right, I'm going to put this back together. We're going to do some tests. Okay, here we go with the DMMCheckPlus test. First, we're going to start off with the 5 volt standard, and this is going to be on DC. And on the Kaiweets, we are getting 5.002 volts. All right, let's switch over to DC, or I'm sorry, AC. And we are getting 4.972 volts. It should be 4.999. Pretty close. It did a little bit better than the HT118A did, so the accuracy appears to be a little bit better on AC voltage. So that's good. And we are showing a 100.0 hertz with a little bit of waver there on the frequency. So let's go ahead and move over. Let's go ahead and check the duty cycle on this as well on the standard. Okay, and we are getting a duty cycle of 49.9%, which is to the best of this meter's ability, and a frequency of 100.0, so we're good there. All right. Let's go ahead and move over to resistance. Okay, and we're going to start off with 100 ohms and work our way up. This should be 99.99 ohms, and it is reading it as 100.3 ohms. Okay, so not too bad. All right, next up we have 1K. And the 1K is supposed to be 1.0005, and it is reading it as 1.001, which is how it should be reading it with this resolution. So that's perfect. All right, next up is the 10K. And on 10K, this should be 10.0044K. This should be reading it as 10.00, and it is. So again, very good. And last but not least, this is the 100K chip, and this should be reading at 100.064. This is reading it as 100.1, which is correct. It is rounded up correctly. So overall, it did pretty good on resistance. Let's go ahead and move over to capacitance. Okay. And we do have a rel feature available here, but it does not look like we're going to have to use it. So we're going to start again from, this is going to be 992 picofarads. Let's see what we get here. And it is reading it as 967 picofarads. It's about 25 picofarads off. More on this later, on this particular range. Next up we have 10.07 nanofarads. And this is reading it as 10.2 nanofarads. So again, a little bit off, but pretty close. Next up is going to be what should be 100.6 nanofarads on this. And we are reading it as 99.93 nanofarads. Okay. And last but not least, we have 1.007 microfarads. Let's see what this gets it as. And it is reading it as 1.030 nanofarads. So again, looks like 1.031 microfarads. So again, it looks like this one measures at 100 kilohertz. I do believe this was rated on at 10K. Yeah, got a little bug in here. Get out of there. All right, so that's going to do it for the DMMCheckPlus tests. No, actually, we got one more thing to do. Let's go ahead and do the current. I'm going to have to switch here. I have to move this red jack. Have to do a little switcheroo here. We're going to put it in milliamps. And actually, that's a nice feature. It just, you know, when I changed jacks, it pushed it right into the milliamp range. So that's a nice touch. Okay, so it's going to beep until we do something. So let's go ahead and start off with the DC first. And on that, we are getting, this should be 0.9996 milliamps. We are getting 1.001 milliamps, 1.000, so I would say it's very close. All right, let's switch over to AC. And we are getting a frequency reading, which is accurate. This is supposed to be 1.001 milliamps, and it is reading it as 0.997 milliamps. So again, it's very close. It's wavering again a little bit. Unfortunately, we don't have a microamp range to check this on, so this is as close as it's going to get, but did pretty well. Okay, here we go with the DC current test for the using the Fnirsi SG-003A. We're going to start off with 4 milliamps, and we are getting 4.017 milliamps. Okay, let's go up to 7. And we are getting 7.025, 7.026. Okay, let's go to 10. and we are getting 10 milliamps even. We did lose a decimal in resolution there. Okay, let's go to 15. We're getting 15.02. That's just about right as well. Okay, let's go to 20. And we were getting 20.02. So overall, pretty decent on DC current. Okay, here we go with the AD584M DC voltage test. So let's go ahead and try patching these in and see what we get here. And of course, I've got the UT8804N patched in as we normally do with this test. So let's see what we get. Here's 2.5 volts. Kaiweets is reading it as the 2.501, and that is correct for its scale. As you can see, we're getting the usual reading in our UT8804N reference. Alright, let's go to 5 volts. And the KM601 is reading 5.008, slightly high, but not by much. 5.0055 is the normal reading we get with the reference meter. Okay, let's go to 7.5 volts. And we are getting 7.507, where it should be 7.502. But again, it's quite close. You know, I don't have any complaints there. All right, let's go to 10 volts. And on the 10 volts, we should be getting 10.00. It is reading it as 9.99. And on the reference meter, we're getting our usual 10.006, 10.007. Okay, so pretty good there. Let's go ahead and try with the 32 with the power supply. So let's do the 32 volt test here. Hopefully I've got enough cable to reach over. And on this we are getting 31.99 volts on the KM601 and 32.015 on the UT8804N. Again, very close. I would call this quite accurate on DC voltage. Okay, here we go with the continuity test on the stock leads. First I'm going to do this in auto mode, and then we'll do it in manual continuity mode where we're just selecting continuity. There's going to be a difference here. Let's see if you can pick it up. Okay, here we go. Kind of slow reaction. Sometimes there's some oily crap on here. So yeah, these need to be cleaned. Alright, let's put this into manual continuity. I think we're going to find that's going to work a little bit better. Oh yeah. Yeah, just fine. These definitely do need to be cleaned off. There is some oily crap on these. But as you can see there, auto mode, for those of you that do like auto mode, that's one reason why I don't like it, because reactivity on continuity is slower, and the reactivity on the other two readings is probably a little bit slowed down also. Okay, so now I've got the probe masters with the continuity test in auto mode, so let's try those. Again, especially on that first one, you know, it had to engage that relay. Yeah. Yeah, it's significantly slower in auto mode. So let me go ahead and put this in, let's just go ahead and select continuity mode. There we go. Now we won't have any relays doing stupid crap. Let's try that again. Again, fast. Zeroes out perfectly. Yeah, I'd say it's just fine. So just be aware that is a reason not to use auto mode. That is one reason why I do not like it. Alright, so we're going to start with the LED lights. So we get red with reading, okay, yellow with reading, green with the reading, and lighting it up nice and bright too. Blue with the reading, nice and bright. white with the reading. We're not getting a continuity beep. It seems to beep when it gets no voltage. Okay, on the RGB there's red, green, and blue. Yep, no problem. Perfect on that. We'll test the voltage output here in just a second. Okay, here we go with the rectifier on the regular diodes. And we're getting .564, so that's good. Next up is the fast recovery. Again, good. All right, next up is the Schottky. Looks good there. Okay, next up is the switching. Looks good there. And last but not least, the germanium. And looks pretty good there. So yeah, I would definitely say this is a very useful device for diodes. Okay, while we're at it, pay attention to this display here. We're going to test the voltage output in the UTN 8804 and see what we get. I think it's going to be a pretty whopping amount. Yep, look at that, 3.093635. Pretty healthy. And as you can see, it does cycle. And I've noticed that on all of these multimeters that do that, that are of this design. They have higher output voltage, but they tend to cycle. And you know, if you were to hold the light, like I'll just show you here real quick. Like just pay attention to this red LED, and it's going to blink off. Yep, see there, it did it right there. So yeah, that's just part of the design apparently. Okay, let's go. Here we go with the resistors. We're going to use the substitution box, of course, since this does have a rel feature, so we can use that. But curiously, this one's not picking up anything. Let me get my hands away from it because I tend to set this off. All right, let's try 1 ohm. Reading it as 0.8. Okay, a little bit off, but not bad. 10, good there. 100. Good there. 1K, we're good there. 10K, yeah, pretty good there. 100K, yep, good there. 1 meg, yeah, good there. 2 meg, just about right. Slightly low, just a little bit low. Actually, that's about right. 4 meg, and again, that one is just about right. Slightly low. All right, let's go to 10 meg. And we should be getting about 9.9 something. It's taking it a little bit while to get there, but yeah, it's just about right. Slightly low, just a little bit. Not enough to complain about. And here's 11, and that's just about right. So yeah, looks pretty good on resistance. Okay, so here we go with the capacitance test. Again, this looks like, yeah, we're not going to need to use the rel. Now let's make sure it works. I think you have to press and hold. Yeah, it does work, but it does not appear that we need it, so we're not going to use it. All right, keep an eye on that. Yeah, we're not getting anything. So let's go ahead. We're going to start off here at 100 picofarads, and it is reading it as 81 picofarads, 82. It's okay. All right, let's try 150. It's okay, a little bit low. It should be reading a little bit higher than 150 on this one. All right, let's try 220. That should be right on. Yeah, that's low. 330. Yeah, again, that's kind of low. 470. Definitely low. 560. This should be reading at about 540. And yeah, it's reading it way low. Okay, 680. And it should be more like 6.64. That's not too bad. 820. Yeah, that's kind of low. It should be more like about 7.5, 7.6. Actually, more like 7.8, I think. All right, let's try 1 nanofarad. Okay, that's fine right there. That's good. 1.5. That's low as it should be, so that's good. 2.2. Yeah, that's good. 3.3. Yep, low as it should be. All right, let's switch over to the high side. Okay, that's a little bit high, but this 4.7 nanofarad is a little bit high. All right, 5.6. That should be a little bit low, and it is. It's okay. It's close enough. 6.8, yeah, that should be around 6.4, so that's good. 8.2, that should be reading more like 8.0, but it is reading it low. So again, I could live with that. 10 nanofarads, that's perfect. 15, slightly high, but not too high. This does typically read high though. 22 should be just about right on, and yeah, that's good. 33 should be a little high, and it is. 47 should be more like 49, and it is. Almost 50. 56 should be a little bit low, and it is. 68 should be around 64-ish. It is picking up low. Again, that's fine. And 100, this should be around 102, 103, and it's reading it as 103.2. So overall, not bad on the capacitance in the low ranges, but it does appear that its accuracy pretty much bottoms out as at around 1 nanofarad. Okay, so let's do some bigger ones here. Let me get this back up here. We're just going to do a few of these. We can try the 22 puff just for grins and giggles, but I don't have much faith in this, but we'll try it. Yeah, nothing. All right, here is 1 microfarad. Okay, yeah, that's just about right. I have noticed this meter is kind of slow on capacitance, especially once you get up in the higher values. Here's 10 microfarads. Yeah, that's fine. Okay, let's try 100. Yeah, pretty good there. All right, let's try 1,000. There we go. Get slower as we get up, but that reading is pretty much what everything else says, so yeah, that's good. I will try the 2200 millifarad. Hopefully it will play nice with me today. Come on. Yeah, there we go. It's up in the millifarad range. And I usually get around 2110, 2120. Yeah, that's pretty good. That's pretty close. I'd say that's fine. All right, let's do the big one. Let's see how long it takes it to read this. It's ranging. Okay, we're in the millifarads. This should be around 9.5 to 9.75 millifarads, and I would say we are good there. All right, so this is, albeit slow, pretty good on capacitors, just that bottom out at the end. And that's going to do it for these tests. I still got a few more to do, so we're going to need to reset here. Okay, here we go with the AC voltage test. So let's go ahead and jam them in here and let's see what we get. And we are getting 122.4 volts, which is just about right, and the duty cycle is correct. Let's go ahead and switch over to the hertz and duty cycle. Let's see what we're getting on that out of this outlet. Yep, 60.07 hertz and 49.8% duty cycle. So yep, pretty good there. I'd say we're pretty accurate. All right. Let's see, next up we've got the NCV and live test. So let me go ahead and do that real quick. Let me get it into that correct mode there. So we're going to start with the NCV. And I'd say that works just fine. Okay, now let's go ahead and do the NCV test. Okay, here we go. The NCV antenna is right here, by the way. Okay, let's try the overhead test. Yeah, I'd say we're good. So the NCV works, it seems to be pretty sensitive. Okay. See, this is what I do not like about, but okay. So we're just going to have to kind of, let me hold it here at an angle that it's not going to, that we're going to get reflective. Okay, so the Thermoprobe is reading 79 degrees. It says about 76 in here, so yeah, okay, it looks like it's adjusting. All right, so let me go ahead and try the body heat test. Reacted pretty quickly. And it is reading about what it gets me to. I'm usually between 92 and 94 on this. Like I said, I'm kind of a cold-blooded SOB. All right. And here we go with fire test. Let's see what happens here. Oh yeah, I'd say we're good there. All right, so the thermoprobes appear to work just fine. Okay, here we go with the frequency test for the Kaiweets KM601. Now, according to the manual, the lower range for this is 10 Hertz and the upper range is 10 megahertz. So I'm going to hit it with a sine wave, the duty cycle of 50%, amplitude of 2.5 volts. Now we're going to start at 1 Hertz and see if it reads it. So let's go ahead and get her going. And it is indeed picking it up. It's reading it as 0.998 Hertz. I would say that's close enough. Let's go up to 10 Hertz. Looks good there. Let's go to 100 Hertz. Looks pretty good there. All right, let's go to 1K. Looks good there. And the duty cycle is holding pretty good. Let's go to 10K. Again, looks really good there. All right, let's go to 100K here. Looks good there. It's also pretty fast. All right, let's go to 1 megahertz. Looking good there. Duty cycle is sagging just a little bit. Getting a little bit of noise in there. Not bad though. Okay, let's go to 5 megahertz. Looks good there. 5.002. All right, let's go to 10. This is its highest rating. And we are getting 9.999 megahertz, so it looks pretty good there. Duty cycle's wavering a little bit, but it's not bad. All right, let's keep going. Let's try 15 megahertz. Getting that. All right, 16 looks pretty good. 17 looking good. 18 and looks like we're losing it, and we do. All right, let's try changing the amplitude to 5. I'll move it up to 5. Okay, we got it back. It's reading it as 18, so let's keep going. I'm not sure how much further this is going to go up, but we're going to give it a shot. Here's 19 megahertz. Okay, it looks good there. 20. And again, we're losing it, and I'm not going to hit it with any more amplitude. But overall, measures well below its spec at 1 Hertz, and will measure all the way up to 19 megahertz. So I will take that. Okay, and here we go with the pros and the cons of the Kaiweets KM601 Smart Digital Multimeter. First, the pros. Well, first and foremost, very good accuracy across the board on all measurements. I have very little to complain about. A couple of minor complaints, but we'll get to that. Really good count resolution, and has a relative function, which to my knowledge, no Kaiweets models before it really did well. The clamp meter that I previously reviewed kind of did, but I wouldn't call that a full-fledged. It was more of a zero function for voltage. And I had also been asked by the Kaiweets rep what I would improve, and count resolution was one thing I suggested, and the other one was the rel feature. So maybe they listened to me, maybe not. Maybe they listened to enough people. Let's just put it that way. This thing is easy to use, no doubt about it. I barely had to look at the manual to even figure out how to navigate this thing. It's just fine that way. Very legible, well-written manual. Nothing to complain about there. It's very easy to read. A little bit wide, but that's only a problem because I'm trying to fit it into a camera when I'm holding up specs for people to see. That's no big deal. Also, the very nice always-on EBTN display. I cannot say enough about this display. This is the best EBTN, aka reverse LCD as I like to call it, display that I have ever seen. It has very few washout angles, and it is very pleasant to work with. So very good job on that, Kaiweets. Built-in jack safety features with the flashy green lights that came over from the HT118A, and I was very glad to see that. That's going to make this thing a lot easier to use for people who are beginners or not very familiar with modern multimeters. So that's cool. And it comes with a nice case. It's a nice hard shell case. It can take a few licks. All right, there are a few cons. So let's go ahead and get to those. It is slow on the higher value capacitance readings. And one other minor complaint I have about it is that this meter is not accurate below 1 nanofarad, whereas its HT118A sibling, as far as I know, can measure all the way down to 22 picofarads because I've done it. I was a little bit disappointed there, but again, it's a very wide, very reasonable range, and it is accurate within its range. There are no dead spots that I can see. No stand. That's probably my biggest complaint about this multimeter. There is no reason why a little, nub stand at the bottom can't be used, because we're not playing with a rotary selector here. We're just hitting buttons. So you don't need a really big stand, but it would have been nice to see a stand on this thing. Auto functions slow down performance slightly. The biggest offender of that is the continuity setting, and I showed that on camera, and it's going to be true of the voltage and resistance as well, although not to the same extent. And the bottom line there is that the relays, are adding to the reactivity time because they have to click in and do whatever. Even when they have clicked in, it's still kind of slow. I would just prefer doing continuity in the manual setting rather than the auto. One other minor complaint is this meter has no microamp range, which was a little bit disappointing considering that it pretty much has everything else. I'm not sure why Kaiweets elected to leave that out, but it is what it is. Anyway, that brings me to the conclusion. Well, I am happy to see that Kaiweets is finally offering a meter that has 10,000 count resolution in the KM601. This was long, long overdue. This is a great choice for an electronics bench, unless of course you need microamp range, and would also be a good choice as an all-around household meter. It has the same safety features as offered by the HT118A, with the green lights indicating which jacks to connect, making it a suitable choice for a beginner. Overall, the KM601 is very accurate across the board, and I definitely would recommend this digital multimeter. So I give it a most definite thumbs up. Like this meter a lot. I'm not a big fan of these smart function meters, but this one changed my mind. Anyway, that's going to do it for me. Hope you enjoyed the review. This is Sui778, and we'll catch you on the next one. Thanks for watching.